Hello everyone, I welcome you all in the logical learning platform. In this lecture, we will discuss standard form of LPP. We'll learn how can we convert a given linear programming problem into its standard form. So basically there are four steps. So before we go to these four steps, so let us see how can we write LPP in in the form of matrix equation. So the objective function is written as maximization or it may be of minimization z. This equal to cx, where c is the vector of coefficients of xi, x is the vector of variables x1, x2 and xn, and constraints are given as subject to. We can write all these constraints as the matrix equation ax equal to b. So this is linear programming problem in short. So how can we convert this into standard form? So look at the first step. Objective function should be of maximize. So if it is of maximization, then fine. But if it is of minimization, how can we convert objective function of minimization into maximization? For this, you need to remember the simple rule: minimization of z, this equal to maximization of minus z. So the simple rule can be used to convert a problem of minimization into maximization. For example, suppose we have a problem minimize z, this equal to twice x1 minus x2. So we can convert it, we can write it maximize minus z, this equal to multiplied by minus, so minus 2x1 plus x2. Further, minus z can be written as another variable, say maximize z dash, this equal to minus 2x1 plus x2, where you can write where z dash equal to minus z. So this is first step. Now all the constraint inequalities should be converted into equations. Now look at this. Basically, we deal with greater than equal to and less than equal to inequalities. So how can we convert these two? For example, suppose first consider this one: x1 plus 2x2 is less than equal to 4. So two cases may be there. This may be equal to 4 or this may be less than 4. So x1 plus x2 less than equal to 4 means something is missing here in the left hand side part. So if we wish to make it 4, then it means we have to add something in the left hand side part. So you can use one variable for this one: x1 plus 2x2, say s1 equal to 4. So this is the variable. This variable is known as slack variable. Slack variable. So the variable which we have added in the left hand side to make it equal to right side. So this is slack variable. Now second example, suppose we have equation x1 plus 2x2 greater than equal to 4. Now if you write greater than equal to 4, greater than equal to 4 means this left hand side part is something greater than 4. It means if we wish to make it 4, then we have to subtract something from this part. So for this we use another variable, say x1 plus 2x2 minus s1, this equal to 4. So here this s1, because we have subtracted, this is known as surplus variable. Surplus variable. So in this way we can convert inequalities into equations. So this is the second step. Now third step, the right side element of each constraint should be non-negative. It means this b, all these b's. So these must be non-negative. So if these are negative, then we'll multiply the equation with minus 1. So in this way we can convert this into a positive value. Now finally, all the variables must be non-negative. This is the non-negative restrictions: x1, x2, x1 greater than equal to 0, x2 greater than equal to 0. It may be possible that for some of the variable this condition is not given to you. Say for example another x3. This is unrestricted. So how can we convert this into non-negative restrictions? So for this, because we do not know whether x3 is positive or negative. So we can write x3 equal to x3 dash minus x3 double dash. Here you can write x3 dash is greater than equal to 0 and x3 double dash is greater than equal to 0. Both are positive. But now look at this. X3 may be positive or negative, because if it is positive it means x3 dash is greater than this one. If it is negative means x3 double dash is greater than x3 dash. In both of the cases these two conditions are satisfied. So in place of x3 we can write x3 dash minus x3 double dash, and here both are greater than equal to 0. So in this way you can convert an unrestricted variable into non-negative restrictions. Now look at some example. So first example is a minimization z x1 minus 3x2 plus 2x3. So here we can write it maximize minus z, this equal to minus x1 plus 3x2 minus 2x3. So we have multiplied this equation with minus 1. So it is minus 1 plus, and here it is minus. Now minus z, you can write it, you can rename it, you can say this is z dash, this equal to minus x1 plus 3x2 minus 2x3. So here you can write z dash equal to minus z. So the problem is maximize z dash equal to minus x1 plus 3x2 minus 2x3, subject to the constraint. Here this is less than equal to, so you can write 3x1 minus x2 plus 3x3 plus s1, this equal to 7. So here this is slack variable. Again this is less than equal to, for second equation minus 2x1 plus 4x2 plus s2, this equal to 12. And similarly for third one 4x1 plus 3x2 plus 8x3 is plus s3, this equal to 10. Now you have 6 variables, so you can write x1, x2, x3, s1, s2, s3 greater than equal to 0. So this problem is now in the standard form. Now look at the second example, is already maximization. So you can write maximize z dash, this equal to x1 minus 3x2 minus 2x3. So no need to change it. Now subject to, so this is less than equal to 7. Again the same as previous one, 4x1 minus x2 plus 3x3 plus s1, this equal to 7. Second one is greater than equal to 10. So we can write it minus 2x1 plus 4x2 minus s2, this equal to 10. Third one is already equal, so no need to change it. It will remain as it is. So minus 4x1 plus 3x2 plus 8x3, this equal to 15. This is already equal, so no need to change this one. So here initially these are not given, so you can delete all these. So you can write x1, x2, x3, s1 comma s2 greater than equal to 0. So this equation is in standard form. Now look at another example. Here this is minimize, so you can write it maximize minus z equal to minus 4x1 plus x2 minus 3x3. Further you can write it z dash equal to minus z, then you can write it maximize z dash equal to minus 4x1 plus x2 minus 3x3 and subject to 3x1 minus x2 plus 3x3 3x3, this is greater than equal to, so we'll subtract one variable minus s1, this equal to minus 7. Next one is minus 2x1 plus 4x2 plus s2 equal to 12. Now look at this x1 and x2, these are greater than 0, but x3 is unrestricted. X3 is unrestricted, so what we can do, we can assume let x3 this equal to x3 dash minus x3 double dash. So these, here we have x3, so these equation will be changed. So we can further write subject to the first one will be 3x1 minus x2 minus 3x3 dash, this is plus 1, sorry, so x3 minus 3x3 double dash minus s1, this equal to minus 7. Second, this one is minus 2x1 plus 4x2, here x3 is not given, so you will write plus s2, this equal to 12. So finally, if you write this objective function here, maximize z dash, this equal to minus 4x1 plus x2 minus 3x2 subject to this, and the variables are x1, x2, x3 dash, x3 double dash, s1 comma s2, all are greater than equal to 0. So this is in the standard form. So in this way you can convert an unrestricted into a restricted, that is in the form of non-negative restrictions. So I hope that you got the concept of standard form of LPP, and now you can convert a given linear programming problem into its standard form. Thank you.